Hey, what's up everybody? This is Brian and welcome back to the Beginning C# with Unity screencast series. So far in this series, you've been working with structs, which are objects. But, believe it or not, there's also another type of object, and that's called a class. A class is very much like a struct. It has state and behavior. In fact, creating a class is very much identical to creating a struct. All you have to do is change one keyword. Like a struct, a class is instantiated using the new keyword. Yet, there is one major difference between a struct and a class. A struct is a value type, whereas a class is a reference type. Throughout this series, you've been working primarily with value types. These are types that are copied when assigned to a new variable. Take a look at this example. Here, you are creating a variable x and assigning it the value of 10. Next, you copy that value to y. If you change the value of y, the value of x will still be the same. This works exactly with structs. Here you can see the struct object is copied and then the name is changed. Game 1 is still named Super Mario Bros., whereas Game 2 is now Half-Life 2. This all changes once the struct is converted into a class. Now, both object names are called Half-Life 2. The reason for this is that when you copied the class object, you weren't copying the entire object like with a struct, but instead you were copying the reference to the object. To understand what this really means, you have to understand how memory is managed in C#. Memory management is a difficult issue in development. Every variable you create uses memory in the computer. The goal of any kind of development is to use memory only when it is necessary. Hold on to it for too long, and you will have what is known as a memory leak. Release memory too early, and you can cause your game to crash. Managing memory is a very tedious part of development, but thankfully, C# manages memory for us. This means the runtime determines when the memory is freed. Memory is divided into two portions, the stack and the heap. The stack is for quick access memory. This is where all the value types live. The heap is for long-term memory, which is slower than the stack. This is where reference types live. Here's how each work. First, we'll start with value types. Each time the code path enters a method, a new frame is created. This frame is called a stack frame and contains all the memory allocation for each value type. As more methods are called, more frames are added on the stack until the code path reaches a point when it starts exiting methods. When that happens, the associated frame is popped off the stack. All the memory used by value types is automatically reclaimed. When you create an instance of a class, this object is created on the heap. The variable pointing towards the object is now called a reference. An object can have many other references pointing to it. When you assign a variable to another variable, you are copying the reference to that object as opposed to copying the object itself. If you create a reference in a method and that method concludes, that reference is discarded, but an object may have many other references to it. This means when a frame is popped off the stack, the class object continues to exist. A class object on the heap only gets reclaimed when there are no longer any references pointing towards it. This is accomplished by references either being popped off the stack or by setting the references to null. With no references to an object, it is orphaned in memory with no way to access it. At some indeterminate point, a process known as a garbage collector will run. The garbage collector scans the heap looking for orphaned objects. When it finds an orphaned object, that is, an object with no references to it, it recollects that memory. As developers, we have no control over the garbage collection process. We can suggest that it run, but at the end of the day, the garbage collector runs when it wants to. Unfortunately, the garbage collector is not a freebie. It does come at a cost, especially when working on mobile. The more objects that you create and discard, the more times the garbage collector will have to run. This costs CPU, which on mobile translates into power drain and could slow down your game. Essentially, you'll want to develop strategies to recycle objects to prevent the garbage collector from running all the time. As a beginner, you don't have to worry about this now, but it's something to keep in mind for future development. In this demo, we're going to create a class object, and by doing this, you're going to see how garbage collection works in C#. So here we have our three main folders: beginning object-oriented programming, control flow, and getting started. Since we're on a new section, we need a new folder. So I'm just going to click this create, and we're going to choose folder here, and we'll call this intermediate OOP. Now within this folder here, I'm going to create a new script, and I'm going to call this minion, like so. And this is just going to be a simple class that contains a minion that has a name. So here we have our minion class. And what I'm going to do first is delete this mono behavior. You'll learn what this means in a few more episodes. We're going to delete all of these as well. So now that we just have a simple public class called minion. This minion class is going to have a simple name, property like so, and I'm going to create a constructor for the minion class. So this is very much like structs. It's going to take in a name, and then we're going to populate the actual name property with it. At this point, I'm going to introduce you to the deconstructor. As you saw with a constructor, you set up and initialize your object right before you use it. A deconstructor runs right before it is garbage collected, and this allows you to stop any processes and deconstruct objects or shut down anything that needs to be shut off before the object is deconstructed. Say, for instance, you had a database connection open and you want to close that database. You would do that within the deconstructor. To make a deconstructor, you simply put in a tilde here, and you can just put minion, the name of the class, like so. And this is your deconstructor. And what this will simply do is just print out the name. Okay, so we have our minion class. Now I want to actually use this. So I'm going to return back to Unity. I'm going to create a new C# script, and we're going to just call this class example. Here we are in our class example script, and what I want to do is create an array of minions. Now, I can use an array that you learned about very early in the series, but instead I want to use a list. A list is very much like an array. It allows you to add objects to it, and it allows you to take objects from it, but you don't have to worry about the fine tuning. For instance, an array is only at a fixed size, whereas a list can grow and shrink. The object manages the size for you. So we're going to create one right now. The way we do this is we type in the keyword list. And for this to work, you need to use the namespace using system collections generic. Now, a list needs to have a type. You don't want to have a list that contains many different objects in it. That could be prone to error. For instance, if you had a list of all spheres in it, and then someone put in a cube in that, that could mess your calculations up. So we need to determine the type of the list, and we use these angle brackets here. So I'm going to create a list of minions like so, and we'll just call this minions. And this is null. Now at start, we're going to create a new list, and we just do it like we do everything else. We type list, and then we pass in the type of the list we're creating. So we're creating a new list of minions like so. Now I want to add to the list. So I type minions, and then I call the add method, and I pass in a new minion. And what I'm going to do is just type new minion, and I'm going to give it a name. And we'll call this one Ted. And I'm going to create several other minions using this way. So here we have Ted, Fred, Ned, and Phil. All are new minions. Now look at how we're doing this. We don't have references to the actual minions. So we're creating a new minion, and we're not assigning it to an actual variable reference. Instead, we're passing it straight into this list. So the list is acquiring all the minions. What this means now is that all the references to these objects are owned by this list. So if we null out the list, then we null out all these classes here because there's no way to access them anymore. Essentially, it makes them all eligible for garbage collection. So we're going to do that right now. And what we're going to do is on disable, we're going to set the minions to null. Now, what's going to happen is that once this is null, all these objects will be eligible for garbage collection. And remember, if we come over to minions here, you can see here we have a deconstructor, and this will simply print out the names. So then you'll see the minions as they're being deconstructed, and you'll get a sense of the arbitrariness of garbage collection. They may be in order, they may not. It's really all up to the garbage collector. Here we are back in Unity. I'm going to select the cube and I'm going to remove this spell script like so. And now what I'm going to do is drag the class example to this. Now we're going to run. I'm going to open up the console, and at this point I'm going to deselect the cube. Now nothing happens right away, but then you can see we have Phil was deconstructed first, Ted, Fred, Ned, then Ed. The other interesting thing to note is that it didn't happen right away. It actually happened somewhat after we disabled the cube. Let's try this again. So we're running, we got the cube, we're going to deselect it. And that time it took even longer for the garbage collector to run, and then all our minions were collected. That's it for this screencast, but as always, we like to end off with a challenge. In your challenge, I want you to create a boss monster class. Give it a name and a point value. Do this in Start and create 2 references to it. Immediately null out one of the references, and then on Disable, null out the other one. This will make the class object eligible for garbage collection and get you used to working with classes. I hope you enjoyed this screencast. Thanks again for watching, and I'll see you next time. In your challenge, I gave you the task of creating a boss monster class, and then I wanted you to null out one reference and then null out the other in on disable, just so that you can get used to working with classes and nulls. Let's do this right now. First, I'm going to select intermediate object-oriented programming, and I'm going to create a new C# script, and I'll just call this boss monster. This is just going to be a very simple class. This is a very simple class. The boss monster is going to have a name, and the boss monster is going to have a point value. And we'll create a constructor. And for the sake of demonstration, we'll create a deconstructor. And we'll just simply write boss monster destroyed. Back in Unity, I'm going to create another C# script, and we're going to call this boss monster example. Here we have our boss monster, so the very first thing we're going to do is create a reference to the boss monster. And we're going to set this to null, so this reference isn't pointing anywhere. Now I'm going to create a new boss monster. And now I'm going to create another reference to that boss monster. We'll call this same boss. And this is also null. Now we have to give this boss monster a name. Now we're going to assign this boss monster to the same boss. Now this boss monster has two references to it. So what we're going to first do is set one of them to null, and then on disable, we'll null out the other value. Okay, we have a very simple error here. Okay, I'm going to select this cube and I'm going to remove this class example script like so. Then I'm going to select the boss monster example and drag it on the cube. And here you can see we have our boss monster example script. We're going to run this. I'm going to open the console and now I'm going to disable the cube. Now we already had one reference nulled out right away. Now we're going to null out the other reference. And there we go. Boss monster destroyed.